x-intercepts, plug in 0 for y. And so x could equal 0, or sine x could equal 0, and sine x is equal to 0 at 0, pi, and 2 pi. And of course, the y-intercept, plug in 0 for x. And so we have 3 x-intercepts, 1 y-intercept. Is there asymptotes? No. No non-permissible values. No asymptotes. Now we go to our derivative. Find our first derivative. And for this, when we find our first derivative, which includes the product rule, and solving this, those second two numbers can only be found with technology. So in that reason, you could, if you had technology, just graph it on your graphing calculator and get the graph. That's what you would do on the exam. But what we're going to do is we're still going to work through the process of finding each of these things if we were following all the steps of finding a graph with our derivative, with our second derivative. So again, if you use your calculator, that's how you could find those things. Oops, wow. There we go, sorry. So here I've graphed the derivative and found my x-intercepts. You could have also just taken your original graph and looked for stationary points, maximums and minimums. You would get those same values. Now if you plug those values back into your original equation, then you would get the actual points. So I could have got the 2.03 and the 4.91 graphing calculator from my max and min, or I could graph my derivative and get it from there as well. Down here. So again, you could graph your second derivative and find its points, 1.0 and 3.64, and then plug those back into the original equation. To find your inflection points. you realize you could also have found your inflection points. That graph was your derivative graph, right? So your stationary points, or your maximums and minimums of your derivative graph, will be places where you most likely are going to get inflection points. So I can find the 1.08 and the 3.64 from that graph as well. So this is just a really good question of getting good with your technology. So it wouldn't be bad later on when you're looking at this question again, see if you can get all of these graphs in place. See if you can do some shortcuts. So we know where it's increasing, we know where it's concave up and concave down. And there is our final graph with x-intercepts, with y-intercepts, inflection points, maxes and minimums. And it stops in 0 and stops at 2 pi because this graph was only asked to graph in that interval.